Step 10, Evaluation and Monitoring. For evaluation and monitoring, we are using the winter vacation activities dataset because this is data which comes from a survey which is done by the Austrian National Guest Survey, and we have these data available for 2 different time points, so we can use it to see what happens to a segmentation which we have been doing on the first dataset. How does it look like if we use data 6 years later? The data is available in package MSA, so we load the dataset, and we have the winter activities our tourists have been doing available for 91 and for 97. And so now we want to use this kind of data to cluster first the 91 dataset and then look how segments changed in membership and how much did they evolve over time. So first of all, what we do is we want to compare these two data sets in the sense, did the overall activity levels for any of the activities change over time? So we are calculating the column averages for 91. This gives us the percentages of activities by multiplying with 100. So we see 71% of our respondents in 91 did go alpine skiing, and only 25% of them did go shopping. So if we do the same for the 97 data, we see that alpine skiing was done slightly less often, with 68% of the respondents going alpine skiing, but 55% going shopping now. So this is an increase in 30 percentage points. So now we could compare each of these two numbers to get a quick overview. We think visualization would be nice, so we're using a dot chart, and we're looking at the difference in activity levels between 97 and 91. We sort those in multiply with 100, so we can clearly see then the pattern of where did the activity levels increase most between the 2 years, where did it decrease most, and we add an x-axis label using this names. We're pasting that together because it's over 2 lines to then have it included in 1 line. And we are also adding a line, a vertical line. This is for vertical at the origin at point 0 with line type 2, LTI equals 2, which means it's a dashed line. And if we can zoom in, we see shopping. That's already the activity where the most change occurred, where 30% difference, whereas cross-country skiing is the activity where there was a decrease between 91 and 97. So we see there has already been some change in the overall level of activities being done, and we now want to investigate how this would impact this change we observe here. How does it impact our segmentation solution? So the first thing we're doing is we are obtaining a segmentation solution for the 91 data. We're loading the package flex class, we set a seed, and we use normal k-means clustering to obtain a 6 segment solution for the 91 activity data, and we can look at the bar chart of this to profile this segment solution and to see who's included in segment 1, segment 2, how could each of them be characterized. So this is the segment profile plot where we use shading to indicate which ones are the marker variables. So segment 1 can be characterized by those who want to go hiking, sightseeing, visit the museum. We want to now compare how do the segment sizes change over time. So we keep the segmentation solution fixed, we keep the partition method fixed, and we calculate how big are segment sizes in 91. So we're extracting the cluster assignments of the respondents and calculate the table. And we're doing the same for the 97 data. So we're using the solution from 91, and we're predicting the cluster membership of the 97 respondents using that solution, and we calculate the cluster sizes. If we want to compare those two, we are bind them together. So first row will contain 91 cluster sizes. This will contain the 97, the second row, and then we calculate the proportional table in the sense that this is with respect to the margin 1, which means row-wise. So we get the proportion of respondents in each of the segments for the 2 different years. We're multiplying by 100 to get the percentages. So this table gives us the information on how big are each of the segments in the 2 years. So we see segment 1 hardly changed in size, which means if we selected segment 1, this is about the same as before. And we see segment 4 dropped in size a lot, so it's more than halved, whereas segment 6 more than doubled. So there has been a distinct difference in the sense that the segment sizes changed, so people seem to move between the segments. We can see if these changes are significant. We can test the null hypothesis that the segment size distribution is the same between the 2 years using a Pearson chi-square test, and this would lead us to rejecting the null hypothesis, indicating that there is a difference in segment sizes. And this could also be visualized using a mosaic plot with shading to give a quick overview how do these segment size distribution differ between the 2 years.